Hello. I would like to bring to your attention some aspects of the paper entitled Development and Validation of an HPLC Method for the Determination of Metformin Hydrochloride. Metformin is among the oldest and most well-studied oral antihyperglycemic agents. Its efficacy has been demonstrated both in the primary prevention of disease and secondary prevention of diabetes-related morbidity and mortality. Because of metformin's proven efficacy, low cost, and minimal side effect profile, it is largely recommended as the first-line, initial monotherapy, and as part of any combination therapy, including with insulin, for the treatment and prevention of type 2 diabetes. In the literature consulted, we noticed the use of the Hplc Analysis method for the qualitative identification and dosing of the active substance content for oral anti-diabetic molecules, from dosed solid pharmaceutical forms. Most research studies state the use of a non-polar stationary phase, C18, the length of the column being variable, and the mobile phase consists of a mixture of 2 or 3 solvents, for example acetonitrile, methanol, phosphate buffer, ammonium buffer, having a pH ranging from 3 to 7. The ratio of mobile phases differs a lot, for example, acetonitrile being used in a proportion of 5% to 65%. The aim of this paper is to develop and validate an analytical method for metformin that is easy, economical, with as few reagents as possible used for the mobile phase, but that can be applied for pharmaceutical forms with the conventional, modified release, but also other pharmaceutical forms containing metformin. To determine metformin hydrochloride, we developed a method of analysis by high-performance liquid chromatography using an Agilent Technologies 1200 type liquid chromatograph equipped with a multi-diode detector. For the development of the method for the determination of metformin hydrochloride by HPLC, we prepared a standard solution obtained as follows: a quantity of 50 mg metformin hydrochloride, reference substance, is dissolved in 25 ml of water, and after complete dissolution it is completed with water at 50 ml, resulting in a solution with a concentration of 1 mg per milliliter. From here we prepared the working solution with a concentration of 500 micrograms per milliliter by dilution with water. A volume of 20 L working solution was analyzed by HPLC using a thermoscientific ODS hypersaltium type chromatographic column, 250 by 4.6 millimeters, 5 m. The temperature in the column compartment is kept constant at 35 degrees Celsius. Detection is performed at several wavelengths in the range of 200 to 900 nanometers. The flow rate of the mobile phase is 1 milliliter per minute. When establishing the operating parameters, we took into account the establishment of the mobile phase, being tested several systems: water, methanol, acetonitrile, water methanol. In one of the tests performed, a water/methanol mixture in the ratio of 80-20 was used. Through its analysis, an asymmetry of the peak is observed as well as a distortion of the baseline. For these reasons, we replaced the water in the composition of the mobile phase with a phosphate buffer, 0.02 molar concentration, adjusted to pH equals 3 with phosphoric acid. It is observed that the distortion of the baseline disappears. The retention time at the top of the peak decreases as well as the width of the chromatographic peak. In connection with the composition of the aqueous phase, in picture 2 it can be seen that we performed several analyses on the same solution of concentration 500 micrograms per milliliter, using acetate buffer mixture pH equals 3, methanol in different ratios, 70-30, 80-20 and 90/10. The conclusion being that the mobile phase will be of the acetate, methanol buffer in the ratio of 70-30. Another aspect considered was the choice of the pH of the buffer system in the composition of the mobile phase. Determinations were performed on the same solution of metformin hydrochloride at a concentration of 500 micrograms per milliliter, using as a mobile phase a mixture of acetate, methanol buffer in a volume ratio of 70-30, in which the acetate buffer solution has different values of pH, 3, 4 and 5. From the comparative analysis of these chromatograms, it is observed in image number 3 that as the pH of the acetate buffer in the composition of the mobile phase increases, an increase in retention time and peak width is obtained. Chromatographically, a decrease in its symmetry as well as a distortion of the baseline. The conclusion is that the pH value of the appropriate acetate buffer is 3. In picture number 4, the study of the influence of the organic phase. Comparative studies were performed by changing the polarity of the organic phase. Thus, analyses were performed in which the mobile phase consists of acetate buffer mixture pH equals 3, methanol, 70-30, and acetate buffer mixture pH equals 3, acetonitrile, 70-30. The comparative analysis of these two chromatograms shows that in both situations, the retention times do not vary significantly when replacing methanol with acetonitrile in the composition of the mobile phase. Another parameter was the determination of the detection wavelength. In this case, we used a solution of metformin hydrochloride of concentration 500 micrograms per milliliter, using a mobile phase consisting of acetate buffer solution pH equals 3. Methanol and a volume ratio of 70-30, obtaining a bit with a retention time of 4.66 minutes, is set at 235 nanometers. The purity of the peak, according to the generated ratio, corresponding to the image of number 6, indicates that the peak obtained is pure. The final chromatographic conditions are displayed on this slide. On these conditions, the validation of the method for determining metformin hydrochloride is performed. The validated parameters were establishing the detection wavelength and building the spectral library, identification of the corresponding metformin peak, linearity, limit of detection, limit of quantification, precision, accuracy, and study of the stability studies for metformin hydrochloride solutions. From the analysis of the absorption spectrum obtained for the standard solution, a maximum at the wavelength of 234 nanometers is observed. For all determinations performed in the validation or practical applications of the method, the wavelength of 235 nanometers was used. The image on the left compares the chromatograms for the reference solution and for a sample, respectively. As seen for the sample solution, the retention time is 5.281 minutes, a value that falls within the required deviation limit, which is plus or minus 15%. By comparing the spectrum of the sample solution with the spectra saved in the spectral library, a report is obtained in which the similarity factor of the peak spectrum in the sample chromatogram and that of the spectral library, obtained by reference substance, is presented. Starting from the stock solution, a number of 3 sets of working solutions were prepared for the study of linearity on the concentration range 10 to 2000 micrograms per milliliter. Each of these samples was analyzed under the mentioned conditions, and from the chromatograms obtained, the area of the peaks corresponding to metformin hydrochloride was determined. The experimental values are given in the table. Because both the correlation coefficient and the regression coefficient have values very close to unity, it can be stated that in the range 10 to 2000 micrograms per milliliter, the developed method has a high degree of linearity. The limit of detection is 10 micrograms per milliliter, and the limit of quantification is about 38 micrograms per milliliter. The data obtained regarding the accuracy of the method can be found in the table on the slide. The average finding in the study of the accuracy of the method for determining metformin hydrochloride by high-performance liquid chromatography has the value of 99.75%. The method is accurate. The repeatability of the analysis, precision of the method, For 3 independent solutions at 3 different concentration levels for the care of the relative standard deviation is 0.8789% with a confidence interval of the values of the environment in the range 98.81% to 100.16%. The intermediate accuracy for 3 independent solutions at 3 different concentration levels for the care of the relative standard deviation is 1.3682% with a confidence interval of the average values in the range 98.09% to 102.28%. In order to estimate the accuracy, it was determined to find for a number of 3 samples at 3 different concentration levels, obtaining an average recovery of 99.75%. 1,000 micrograms per milliliter and 2,000 micrograms per milliliter were analyzed under the method at intervals of 0, 24 and 48 hours after preparation, the solutions being stored in the refrigerator, at room temperature and in a water bath at 37 degrees Celsius. By integrating the obtained chromatograms, the areas of the peaks corresponding to metformin hydrochloride were determined. Then, using the equation of the regression line, the concentration in metformin hydrochloride was calculated. Analyzing the data, it is found that metformin hydrochloride solutions are stable for a period of 24 hours after preparation, but the percentage content decreases after 48 hours after preparation. The solutions kept in the refrigerator have the best stability, and as the storage temperature increases, the stability decreases. In conclusion, the method can be applied to determine the metformin hydrochloride content of tablets, the samples being able to be analyzed within a reasonable time. In the case of stability studies, due to the large number of samples, the solutions collected at different time intervals will be stored in the refrigerator, and will be analyzed chromatographically in a maximum of 24 hours. To verify the developed and validated method, we performed the quantitative determination for metformin hydrochloride tablets purchased from pharmacies. 5 pharmaceutical products were chosen that were previously coded, tablets with concentrations, type of tablet in different countries. All 5 products analyzed were appropriate, the finding being within the allowable deviation of ±5%. A method of analyzing metformin hydrochloride was developed by high-performance liquid chromatography, establishing working conditions. Chromatographic separation is performed using an Agilent Technologies 1200 liquid chromatograph, a thermoscientific ODS hypersaltium type chromatographic column, 250 by 4.6 millimeters, 5 micrometers, with a mobile phase consisting of a mixture of methanol, acetate buffer, pH equals 3, in a ratio of 30-70 at a flow rate of 1 milliliter minute, the temperature in the column compartment being kept constant at 35 degrees Celsius. The volume of injected solution is 20 microliters. The detection is performed in UV at a wavelength of 235 nanometers. 2. The detection limit, LD equals 10 micrograms per milliliter, and the limit of quantification, LQ equals 38.35 micrograms per milliliter, were calculated using the estimation of these limits based on the signal-noise ratio. 3. To estimate the accuracy, it was determined to find for a number of 3 samples at 3 different concentration levels, on the range 70 to 130%, obtaining an average recovery of 99.75% on the range 98.12 to 100.93%. 4. Metformin hydrochloride solutions are stable for a period of 24 hours after preparation, the percentage content decreasing by less than 1%. However, it is recommended to keep it in the refrigerator until analysis. 5. We determined the metformin hydrochloride content of both conventional and modified release tablets, which confirms that the method can be applied in future research. Thank you for your attention.